Coming up next, we have exciting debate regarding small versus large NLP models. In this Fireside chat, we have ML NLP expert, Dr. Ashutosh Modi, Assistant Professor at Computer Science and Engineering Department of Indian Institute of Technology, Kanpur, and Elucidata's BioNLP Director, Shashank Jatav. As the world is towards larger models to improve accuracy, they're taking a step back and looking at the technology and exploring how it can be improved. Over to you both.
Hey,
Yeah, thanks.
can I share my screen? So we can get started. Here we are going to discuss something that is both troubling as well as enabling us, a debate between large and small models. And why David versus Goliath? It's not really now a David versus Goliath. If you've heard of stability AI and people taking on the big giants like OpenAI. So even in the large, there is a large model. There is a David versus Goliath. But and we'll talk more about large versus small models and how does this David versus Goliath things play out. Okay, so the agenda here is pretty simple. We'll talk about some expectations. And we'll ask Professor Ashutosh questions about like how legit are those expectations. We'll talk about real life AI adoption, and we'll talk about some basically whether AI is solving a right or a wrong problem. What is the problem, for example? Something that Abhishek touched on his talk as well. Okay, so let's get started with Iron Man, Batman, our favorite characters. So why we are talking about this? I mean, because there has been a gigantic wave of big models in recent months that took us by surprise. They're also like pretty impressive. They do pretty impressive stuff. I mean, people who are not familiar with large models like painting, writing papers, translating, making videos, and God knows what. So what's wrong, right? Well, most of us can't run these models, can't debug them, don't know why they work like this. Are these silver bullets to some of the problems that we have, right? But these are like some very important progress that, I mean, I would say humankind has made in the past. And we see the result as these big models, but there are some things that we need to consider before calling it a win, right? So, and talking about, of course, like Iron Man, Batman. So we are all fascinated by Batman and his gadgets. He seems to always have right tools at the right time, all the time, basically. He also has an AI in his Batcave. I'm not talking about Alfred here, but it seems to basically have a custom solution ready for every new villain every time. I think in the older days it was called Bat Computer, but correct me if I'm wrong. Let's move into future a bit and come to Iron Man. I mean, of course, AI takes the shape of Jarvis and evolves into Ultron. Both are products of money thrown at a problem that they are taking for granted to get a solution to the problem. There are countless such stories where AI is supposed to solve all the problems, both humanly as well as superhumanly. Humanly in the sense that they need to have a general intelligence and solve problems in a very intuitive way, and superhumanly that they can handle massive resources and they can solve anything faster than any human being on Earth, right? Remember Ultron, he can travel multiverses, for example. But that's how actually our civilization evolved. Like we have all these mechanical machines which evolved to take place of the low labor that human beings used to do, and it allowed humans to do unthinkable, like moving mountains, building skyscrapers, etc. Professor Ashutosh, like, do you have any recollections of any other childhood AI fascination? Just covering the generational gaps here.
Yeah, so I mean, AI, for me, like AI fascination actually came from I don't know if you have read these Isaac Asimov's books, basically. So there, I mean, you have, and also there was a movie made out of that, like 2001 Space Odyssey, right? So
Yeah.
in his books, he talks about like future. I mean, he in fact talks about like, I mean, 20th century, 21st century, when all these things will be kind of very trivial. So that kind of fascination kind of hit me quite a bit, right? I mean, in his books, I mean, like solving like NLP problems was like kind of very trivial thing, and it was assumed that these will be solved by the time like we develop like robots and stuff. But I mean, we are still not there. We are still kind of pretty far behind. So I mean,
Yeah,
in
and you
yeah,
worked at
yeah,
Disney, so you already have worked at the place. Yeah,
yeah,
pretty cool. Yeah, so I mean, AI fascination is definitely old, but I mean, there is this um, I mean, the title of the slide is growth, growth, growth. So, this is basically a figure taken from Tim Urban's Wait But Why. If you have not seen his blogs, then I would strongly recommend. These are very long blogs, but very insight driven. So referring to the Tim Urban's blog, human progress is always underestimated. So you can see that they are saying, or the Tim Urban is saying that there are bad predictions happening, and because of that, we lose on some of the momentum that we have. And that is true for some, I mean, for industrial revolution per se. But and he also emphasized that there is this S curve where there is basically an exponential growth, and then there is a flattened progress there. So I mean, that's where I think critics play a role, and basically, and the expectations what we have of of this kind of a trajectory might not be always real. So this is something that is like quite generic. So coming back to like what does this mean for AI's future? I think like for AI, at least like we don't know for sure that whether there will be an exponential growth or not. Clearly, there are some there are some progress there, but we still need to see some of the like expectations to come to fruition. So, as a person, Professor Ashutosh, as a person with experience working in different areas of NLP, like natural language understanding, biomedical, and low resource languages, what are your thoughts on this? Like, how realistic are the expectations that are being floated around ML and its applications?
yeah. As you rightly said, like I mean, if you look at past in the past decade, there has been a lot of growth, and it's almost looks like it's been a kind of exponential growth, basically, right? So yeah, I mean, many of these technologies are quite promising, and there has been a lot of progress, but I think we are still very far from what I mean, if you compare, let's say, to let's say a human or a normal person, we are still very far, I mean, far from what we would like to achieve, basically, right? So I mean, all these models, I mean, you might be aware of these GPT-3 and all these big huge models. Basically, they have been trained on huge amount of data, and they've learned a lot from this data. But uh, so I mean, but we don't know, I mean, it's not really clear to me, do they really understand what they have learned, basically, right? So they have picked up a lot of good patterns from a huge amount of data, but do they really understand? That's not clear. I mean, people have, I mean, this is an active area of research where people are trying to probe the models to understand if the models really understand something, basically, right? And this also kind of comes into this Chinese room argument kind of situation where, like, I don't know if you're aware of that, like
No.
where yeah, so you're not aware. So yeah, I mean, very briefly, what it says is like you might have a system where you give a set of symbols, maybe let's say in Chinese, and it would translate it back into English, basically, right? So it's a perfect system, and it's perfectly translating, but it doesn't really understand what it is translating, basically, right? So so that kind of illusion we might be having for the models right now. I mean, still it's kind of quite early stage, I would say. But I'm in general, I'm quite optimistic. I mean, we definitely are going on a, seems to be like on a good path or right path. And as you say about this S-shaped curve, right? So that's something, is something similar is also happening. Like for example, we started, I mean, if you look at, let's say 2010 or maybe 2012, right? So we started with this revolution with CNNs, and then CNNs were like the thing. And then after a while, it kind of plateaued out. Then the LSTM and RNNs came into picture, right? And then that seemed plateaued out. That was also
And
like a very fast
transformers are
growth.
everywhere.
Now transformers, then possibly something after transformers will also come more. And but the thing to note is that everything builds on the previous thing, so it's kind of an incremental progress, right? It doesn't happen like it's not magic essentially, right? So incrementally things develop, and it all builds on the previous failures or the previous limitations. So I think going that way, we will be. I'm optimistic we will be achieving pretty good results in future as well. But we are still very far. I wouldn't say that. I mean, you might be knowing about this AI singularity, right? So we are still very far from that singularity thing. My estimate would like at least 20-30 years more before we actually reach that point. And if we reach that point,
Well, Elon Musk says 5 to 6 years more.
I don't know. Yeah. I mean, I don't know. He has access to more data than me, so maybe.
Yeah. So talking about the great expectations, right? I mean, we see psychic models with a disdain that these are very small, or traditional ML as with disdain, and like deep learning and AGI is general intelligence, and basically those as like being very all powerful. So yeah, I mean, while the idea of artificial general intelligence is excellent, again, like we have not properly defined what is AGI, what is that general intelligence, right? Most folks are like trying to find the resemblance to human nature, for example, summarizing a text, making a real life painting, performing algebra or arithmetic. And also like the news around these are that it makes you believe that these models are superhuman, while in reality, they just reach about 50 to 60% of the expected AGI levels. In our internal assessment, also we found out that like it's a very like telling story that while the Polybird, which is significantly smaller than other very big models, the accuracy on biomedical data decreased with increase in size of the model, and basically the 175B model could not perform very well because it does not have PubMed data as training, and that tells you something. And also like the GPT J60 model, which has PubMed data and is training, it's not doing that great. And sometimes we also actually found Chinese symbols spitting. These models actually spit out Chinese symbols while when we ask questions to them, and basically, yeah. So it seems like bigger is not always better, and you already talked about expectation, but like you have worked on multimodal machine learning, sign language processing, translation, and legal AI, which are very different in terms of context, training data, and expected outcome, right? But in your world, basically, what do you think about the expectations that we have of AI today?
Yeah. I mean, I will like to point towards the initial thing that you were saying about the AGI, right? So yeah. So personally, I don't really believe in AGI, which might sound a little kind of anti to what most of the people nowadays believe. Because see, I mean, if you look at humans, for example, humans are not kind of generalists; they are more kind of specialists, right? I mean, the whole human society, if you see, it's based on the concept of specialization. Everyone specializes in one particular trade, and for a human to kind of specialize in multiple trade, it takes time. It takes a lot of time to kind of reach that level. I mean, you might be knowing about this 10,000 hour rule, basically, right? It takes 10,000 hours to master one skill or some new thing, new concept, a new art, basically, right? So the thing is, so I don't really see.
And that's what we see. Yeah, that's what we see in these GPT models as well. When PubMed data is not actually part of the training data, you don't see that accuracy as well.
Yeah, so I don't really see a point in developing a model which could do everything, or maybe a system which could do everything, rather than having smaller specialized systems might make much more sense. Because I mean, in the end, what we want is we want to achieve certain, we want these models to do something for us, right? And we don't really care if they're not able to do something else, basically. If it is able to, let's say, if you have a, let's say, a model which does some kind of sign language translation, we only are interested in how good that translation is. We are not really interested in if it is able to, let's say, predict the, let's say, the named entities in a biomedical text, your dual algebra. We don't really care, right? I mean, so same, I mean, you don't expect, let's say, a human translator to be good at algebra. I mean, why? It doesn't I mean, doesn't matter to you, right? I mean, if they're good at
And
algebra.
why is there such a need to be AI to be human-like, rather than like,
yeah, I think it's more of a benchmark. That's it's like, I mean, you are trying to develop something which is intelligent, and the next the best possible intelligent thing that you see or around yourself is human, right? So it's more like that comparison kind of comes in automatically, right?
and maybe it is easier to market or easier to show the impact as well.
Yeah, obviously, yeah.
Yeah. So yeah, I mean, like, this is a very interesting story that I would um, say really quickly. So there was this horse in old times where basically the horse could do arithmetic actually, and people from far away used to come and see the horse, and nobody really know how the horse could do an arithmetic. And turns out that the horse didn't know any arithmetic, and that's what Ashutosh said earlier, that explainability is a very big thing in AI, and the horse basically only relied on his owner's cues to basically uh, tell what is the sum or a fraction or something like that. So it's a very good story. It's from Gary Marcus, so I would strongly suggest you to read his blogs on it. Yeah, so coming quickly to real life AI adoption, big versus small. Again, we see a trend that a lot of these models are just increasing in size, and we are getting more and more such models. But these pale in comparison with the models that we see in our day-to-day lives. Like Google's recently released a Pixel Pro where you can unblur the photos. Grammarly helps you correct the grammar. iPhones like basically released a lot of stuff, which which I sometimes find funny. But I mean, it's question about like few versus billions of devices. And how do you see this, Professor Ashutosh?
Yes. See, one thing which I want to clarify here is that, see, the smaller models that are usually deployed on these edge devices or mobile phones, basically, right? So these are actually kind of a distilled version or kind of a stripped down version of the larger models which have been trained on enormous amount of data. So it's not really that, I mean, you have like a smaller model which might be doing really well. I mean, it's actually derived from something bigger, right? So that's one thing. But these large models also come at a very big cost, right? I mean, if you look more from, let's say, the climate perspective, so I think there was this estimate, like the amount of energy that is used to train the GPT-3. You could, I think, if I remember correctly, you could, I mean, power like 100 houses for a year with that much energy. So now you can imagine like I mean, how much energy these are consuming. And if you compare these to, let's say, human brain, right? I mean, human brain consumes around approximately around 20 watts of power in a day. So I mean, and
So
does
maybe we'll
much
see this. Yeah,
and does much
we'll see
better
the similar.
than GPT-3, right? So
yeah.
so that trend is there. So my main concern about these models is I mean, they are I mean, they're not I mean, first of all, I mean, there is a limit after which they will kind of plateau out there on the performance. And also, I mean, they are not what like a human brain is doing actually, right? So perhaps some changes in the architecture, more research on that side is definitely needed, which are more efficient models, more compact architectures are definitely needed, right? So because definitely this will hit a threshold, hit a ceiling at some point, basically, beyond which, I mean, it's going to be kind of a diminishing return kind of situation.
So large models will become a small one, I guess.
Yeah, I mean, yeah, but that needs a lot of research, right? I mean, ideally, we would like that. I mean, because if you see brain, it is kind of a much more smaller model and much more energy efficient, right? So ideally, that's what we would like to achieve, basically.
Yeah. So coming quickly to the AI for wrong problems, I mean, I would quote, simply like quote one of the a very cool blog that I read, like basically that if you put AI in a position of making a decision, they are not a great systems to make a decision. But because like AI outcomes are not one model but a stakeholder exercise, for example, in in the case of healthcare, there are like several stakeholders. Even if you give them a lot, like the most clean data in the world, the best outcome, they will still basically try to compromise to make a decision. So AI can help in making a decision, but not really like replacing it. So, Professor, have you seen in the case of big models that are trying to replace artists or academics or judges, for example, in the legal AI case? Do you think that it is better to have models that can help artists communicate or aid academicians, or do you think like AI should make judgments? Or what is your take on that?
Yeah, so see, so I've done, I mean, as you said, right, I've done research in the legal AI domain. So my belief is that these systems should augment humans, or let's say legal practitioners or judges, rather than replace them. Because see, what happens is, I mean, fundamentally, if you look, the way these models are trained is very different from the way humans or human judges get trained, basically, right? So humans also take in a lot of other information which these models never take into account, right? I mean, when a judge is making some kind of judgment, he's taking into account these societal things that are there associated with that person, the background, and lots of other things, a lot of other factors which they also learn from experience. But these models never take. I mean, it's not possible to train all these things or feed all these things into model. I mean, practically, basically, right? So.
Yeah.
Models are most likely going to predict just based on the laws which have been written, basically, right? But laws may not cover each and every aspect of the society. So I think the models should be more of a kind of should serve the purpose of augmenting the specialist rather than replacing them. And I think similar argument applies for other domains as well. Like, I mean, I don't see models completely replacing doctors. I mean, they could definitely augment them very well, but I would be really, I mean, in fact, as a human, I would also be very skeptical about being kind of diagnosed by a AI system, basically.
Yeah. Okay. Okay. Thanks, Ashutosh. That was really good. And if you have any questions, then yeah.
Well, thank you, both of you guys. That was a fun conversation to be a part of. There were actually a lot of questions in the Q&A, but we do not have time to go over them, but they're active, on the Q&A section, and you can be active over there. But thank you.
Thanks.